As you know, your running chapter is trigonometry. Now we discuss in part second trigonometric ratio of some specific angles by geometrical method. Here is a very important. Now look that later equilateral triangle, all sides are equal and all angles are 60 degree. Now let triangle ABC be an equilateral triangle with each side equal to 2a. Here we take the side, each side is 2a. Let the side is 2a. AB, BC and CA 2a. Clear? Then each angle of the triangle is 60 degree. As you know that equilateral triangles angles are 60 degree. Clear? All angles are 60 degree. Now look here, angle A, angle B, angle C is equal to 60 degree. Now draw perpendicular AD from A to the side BC. Here draw perpendicular from A side BC. There is a perpendicular. This one is a 90 degree. Clear? So ADB and ADC. Here is the two triangles. Clear? Both triangles are congruent. We use here the congruency rule RHS. Right angle, hypotenuse and side. Right angle, hypotenuse and one side is common. So these two triangles are congruent triangle. Clear? Now perpendicular triangle ADB is congruent triangle ADC by the rule of RHS congruence rule. Clear? Now BD is equal to DC. BD is equal to DC. Then we draw the perpendicular bisector. So this one is divided in two parts. So this one is the 2A. In divide two parts, A and A. So BD is equal to DC is equal to A. Clear? Right angle triangle ADB. Now take the right angle triangle ADB. ADB. So we use here the Pythagoras theorem. Here use the Pythagoras theorem. Find AC. So AB square is equal to BD square plus DA square. We find DA. So DA square is equal to, now look here, AB square is equal to BD square plus AD square. So AD square is equal to AB square minus BD square. So AD is equal to under root AB square minus BD square. Now given that AB is 2A whole square and BD is given A. So A's whole square we get here 4A square minus A square. So what we get when we minus them? 4A square minus A square, we get here root 3A square. So AD is equal to under root 3A. Clear? Now discuss here for the angle 60 degree. For the angle 60 degree. Clear? In triangle ADB. Which triangle? Triangle ADB. Triangle ADB. Now take angle. Now here take angle sine 60 degree. Sine 60 degree. We use here the Pandit Badri Prasad Har Bole. Pandit Badri Prasad Har Bole. Sine 60 to write now P by H. P by H from the perpendicular upon hypotenuse. Perpendicular is given that AD upon AB, and AD is now find under root 3A by 2A. 2A is A cancel. Now we get here under root 3 by 2. Clear? Now find the cos 60 degree. Cos 60 degree is equal to B by H. Base by hypotenuse. Base by hypotenuse. Base is given that BD and hypotenuse is given that AB. So BD's values A and AB's values 2A. This one is the cancel. We find 1 by 2. Similarly, tan 60 degree, tan 60 degree perpendicular upon base, perpendicular AD and base is BD. Under root 3a by a is cancelled, we get here under root 3. Similarly, cosec 60 degree, cosec 60 degree just opposite of sin 60 degree. So this one is right 1 upon sin 60 degree. 1 upon under root 3 by 2. So this reciprocal, so 2 is up goes numerator, 2 by under root 3. Similarly, sec 60 degree just opposite of cos 60 degree. So 1 upon cos 60 degree, 1 by 2. This one is 2. Clear? Now cot 60 degree just opposite of reciprocal of 1 tan 60. So 1 upon tan 60 is value under root 3, 1 by under root 3. This one is 1 by under root 3. For the angle 30 degree in triangle ADB. Now look the figure for the angle 30 degree. So this angle, so now this one is the base, and this one is changed into perpendicular, and this one is the hypotenuse. Clear? For the angle 30 degree, AD is the base, BD is the perpendicular, and AB is the hypotenuse. Now look here. For the angle 30 degree in triangle ADB, sin 30 degree is equal to perpendicular upon hypotenuse. Perpendicular is given BD upon AB. So A upon 2A. This one A to A cancel, 1 by 2. Cosec 30 degree just opposite of sin. 1 upon sin 30, 1 upon sin, 1 by under root 2. So this one is a reciprocal, 2 by 1. This one is a 2, value 2. Cos 30 degree is equal to base upon hypotenuse. Base upon hypotenuse, base is given that AD and hypotenuse is given that base is equal to AD and hypotenuse is given AB. So AD is given that under root 3a and AB is given that 2a. A से A cancel. What we get here? Under root 3 by 2. Similarly, cos just opposite of sec. So sec 30 is equal to 1 upon cos 30. So 1 upon under root 3 by 2. This one is goes numerator, 2 by under root 3. Clear? Now tan 30 degree is equal to perpendicular upon base. Perpendicular is given that BD, base is given that AD. So A upon under root 3a. A से A cancel. What get we? 1 by under root 3. And cot 30 is just opposite of sin tan 30. So 1 upon tan 30 is equal to 1 upon under root 3. So this root 3 goes up. So root 3 by 1. So this one is right under root 3. Clear? Now trigonometric ratios for angle of 45 degree. Clear? What is the angle of 45 degree? Let us take a right angle triangle ABC, and this one is a 90 degree. Clear? So this one is a 90 degree and one angle is a 45, the other also is 45. So AB is equal to BC, isosceles triangle. Clear? Yeah, we said that side of opposite to equal angles of triangles also equal. So this side equal to this side. Angles are equal, so their opposite sides are also equal. Clear? Now let triangle ABC be a right angle triangle in which angle B is equal to 90 and angle A is equal to 45. Clear? And angle C also 45. Let side AB is equal to A and is equal to BC. Both are equal. Side and opposite side angles are equal, so sides are also equal. Clear? So side opposite to equal, angles of triangles are also equal. Now use here the Pythagoras theorem. Find this side AC. So AC square is equal to AB square plus BC square. Now AC is equal to under root AB square plus BC square, and AB and BC's values given, put here. So A square plus B square, this one is right, under root 2A square. So AC is equal to under root 2, and is A square is square root is A. Clear? So sine 45 degree. So angle for the sine 45 P by H, perpendicular upon hypotenuse. So BC is a perpendicular and this one is a hypotenuse. AC is a hypotenuse. Now look that sine 45 degree P by H, perpendicular upon hypotenuse. Perpendicular is BC upon AC. BC's values A and AC's values we find that under root 2A. So AC cancel, what we get here? 1 by under root 2. Sine 45's values 1 by under root 2. Now cosec 45, just sign opposite. So 1 upon sine 45, 1 upon sine 45 value, 1 upon under root 2. This one is goes up numerator. So under root 2 by 1, this one is under root 2. So cos 45 degrees values 2. Cosec. Cos 45 is equal to B by H, base upon hypotenuse. Base is given AB and hypotenuse is given that AC. So A upon under root 2A. So this one also 1 by under root 2. So sec 45 degree, just opposite of cos 45 degree. 1 upon under root 2. This one is root 2 is equal to root 2. Now tan 45 degree. Tan 45, this one is a perpendicular upon base. Perpendicular is BC upon base is AB. BC is equal to A and AB is also A. A by A we get here 1. So tan 45 degrees values 1. And cot 45 just upon opposite of reciprocal of tan 45. So 1 upon tan 45, 1 by 1 is equal to 1. Clear? Now we discuss here trigonometric ratio for the angle of 0 and 90 degree. For the angle 0, that here is a 90 degree right angle triangle ABC. Clear? Here is angle A. Now look that in a triangle ABC, as angle A gets smaller. Clear? As angle A gets smaller and smaller. जैसे जैसे हम एंगल A को स्मॉल और स्मॉल करते जाएंगे, the length of the side BC also decreases and the point C gets closer to the point B. Point C. This point is closer to the point B. Closer to the point B. Finally, when angle A becomes very close to 0 degree, as becomes almost the same as AB and BC. AB and BC are almost same, gets very close to 0. Clear? Now, so the value of sine A, BC by AC is very close to 0. Also, when angle A is very close to 0 degree, AC is nearly the same as AB, and so the value of cos A, AB upon AC is very close to 1. Clear? Now look that figure. Now here is the figure. Right angle triangle ABC. When C point is close, the angle is decreases. Clear? Point C is close. Angle and small. Then point is closer to B and then 0. So B and C same. AC and BC are collapse or coincide. Clear? Thus, when angle A is equal to 0, so sine 0 degree is equal to 0 and cos 0 is equal to 1. Clear? Now say for the angle 90 degree in triangle ABC, as angle A gets larger and larger, the angle C gets smaller. Angle A increase करेगा, C is smaller and smaller, and the length of the side AB goes on decreasing, and length of side AB also decreasing. Point A gets closer to the point B. Finally, when angle A is very close to 90 degree, angle C becomes very close to 0 degree, and the side AC almost coincide with side BC. Now look that, so sine A is equal to BC by AC is very close to 1. Also, when side AC is nearly the same as the side BC, the angle A is very close to 90 and the side AB is nearly 0. So cos A is very close to 0. Now look the figure. Here is the first step. ABC is a right angle triangle. When this one is close, clear? Angles are increases, clear? This one, please. And at last, AC and BC are coincides. AC and BC are coincide. These points, clear? Okay. Thus, when angle A is equal to 90 degree, so sine 90 is equal to, we know that पंडित बद्री प्रसाद हर हर बोले के थ्रू, तो साइन थीटा साइन 90 P by H perpendicular upon hypotenuse. Perpendicular is BC and hypotenuse is EC, and now here is BC is closer to change into AC is changed into BC. So BC upon BC is equal to 1. Cos 90 degree base upon hypotenuse AB upon AC, AB becomes 0. So 0 upon AC we get here 0. Tan 90 degree is equal to perpendicular upon hypotenuse. Perpendicular BC and hypotenuse is perpendicular BC and base is equal to AB. BC upon 0. This one is a infinity, not defined. Clear? 0. This one is infinity, is not defined. Cosec 90 degree is equal to 1 upon sin 90. 1 by 1 is equal to 1. So cosec 90 is 1. Sec 90 degree 1 upon cosec 90. So 1 upon 0. This one also not defined. Infinity. Now cot 90 is equal to B by P, base upon perpendicular. Base is 0, a perpendicular BC, so this one is get here 0. Clear? Now look the chart of this angle 0 or 0 degree or 0. Clear? 30 or pi by 6, clear? 45 degree or pi by 4, 60 or pi by 3, 90 or pi by 2. These are the values. Sin theta, 0's value 0, 1 by 2, 1 by under root 3 by 2 and 1. This one, look this one, to just opposite of sin theta. Sin just opposite of cos 0 by 1, 0 by 1 this is infinity, cosec 1 by 1 get again 0 by 1 when infinity. When we get in these three we find these also these three just opposite. Clear? Now note here the value of sin theta is increases from 0 to 1 and cos theta decreases from 1 to 0, where 0 is less than or equal than theta and theta is less than or equal than 90 degree. In second note, in the case of tan theta, the values increases from 0 to infinity, where 0 is less than or equal than theta and theta is less than or equal than 90 degree. Clear? Now another trigonometric ratios of complementary angles. Complementary angle 90 minus theta. Clear? Now here take a right angle triangle ABC. B is a 90 degree and A is a theta, and this one is a 90 minus theta. Clear? Consider a triangle ABC in which angle B is equal to 90 degree. We know that sum of triangles angle sum is equal to 180 degree. The angle A plus angle B plus angle C is equal to 180 degree. Clear? Triangles angle sum property. So angle A plus angle B is equal to 90 plus angle C. So we get angle A plus angle C 180 minus 90. So angle A plus angle C is equal to 90 degree. So angle A is equal to theta degree. So theta plus angle C is equal to 90 degree. The angle C is equal to 90 minus theta. This one is a complementary angle. Clear? Now look here in triangle ABC. In triangle ABC, look the triangle ABC. So this one is a hypotenuse, this one is the base, and this one is a perpendicular. Now look that sine theta. Sine theta, clear? We take here Pandit Badri Prasad Har Har Bole, P by H. Sine theta is equal to P by H. P by H here BC upon AC is equation first. Now cos theta. Cos theta is equal to B by H is equal to BA upon AC is equal to second equation. Tan theta is equal to P by B perpendicular upon base. BC upon AB is the third. Cosec theta is equal to just opposite of sine AC upon BC. Sec theta just opposite of cos, so AC upon PA, AB, and cot theta is just opposite of tan AB upon AC is fourth condition. Here, clear? Now we discuss here, we draw here for suitability. Now here change this one. Now take here complementary angle. So this angle is C. So this one is the base and this one is the perpendicular and this one is the hypotenuse. For the angle C, this one is the perpendicular, this one is the base, and this one is the hypotenuse. Now look that sine 90 minus theta. Sine 90 minus theta, here is P by H. P perpendicular upon hypotenuse. The perpendicular upon hypotenuse AB upon AC. So AB upon AC cos theta. From second equation we already proved cos theta is equal to AB upon AC, or sine 90 minus theta is equal to AB upon AC. So this one is right, cos theta. So we find that sine 90 minus theta is equal to cos theta. Clear? Now look here, cos 90 minus theta. Cos 90 minus theta is equal to B by H, base upon hypotenuse. Base is BC. Base is BC and hypotenuse is AC. So BC upon AC, this one is equal to BC upon AC is equal to sine theta from equation first. We already proved that sine theta is equal to BC upon AC in equation first. So this one cos 90 minus theta is equal to right now sine theta. Clear? Tan 90 minus theta perpendicular upon hypotenuse. Perpendicular upon hypotenuse. Perpendicular is given that AB and hypotenuse is given, base is given that BC. So AB upon BC is equal to cot theta from equation 6. Clear? Already we proved that cot theta is equal to AB upon BC. So tan 90 minus theta is equal to cot theta. Cosec 90 minus theta is equal to Hypotenuse upon perpendicular AC upon AB is equal to sec theta from fifth. Similarly, sec 90 minus theta, hypotenuse upon base, AC upon BC. This one also proved that cos sec theta is theta from fourth. Now, cot 90 minus theta is equal to B by P is equal to BC upon AC is equal to tan theta from equation third. Clear? Okay. We discuss some other solutions in next video.